f of x equal to x plus 4 squared and x minus 2. We want to be able to find the x-intercept and the y-intercept and then graph it. Oopsie. Okay, so how do we find x and y intercept? For x-intercept, we set y equal to 0. For y-intercept, we set x equal to 0. Thank you. All right, so the first one, y is 0, equal to x plus 4 squared, x minus 2. So x will equal to what? Negative 4, and then x equal to 2. And are they going to be crossing or touching? The first one have an even power 0. Touching the point, touching the x-intercept. The second one, I don't really see an exponent here. What does that mean? It's a 1 here, so it's an odd power 0, which will represent crossing. Okay. Everybody okay with the x-intercept? Okay, for y-intercept, we set x equal to 0. So y equal to 0 plus 4 squared, 0 minus 2, right? So we plug in the 0 there. So y is going to be 4 squared is 16 times a negative 2, so y equal to what? Multiply. Negative 32, is that right? Okay. So we have the x and y intercepts. What degree is this function? This is a degree 3, because like 2 here and 1 more, right? Like you have like an x squared and then an x, right? Together is going to be 3. So degree 3 and the leading coefficient a is going to be what? Positive or negative? Yeah, positive at the beginning and times another positive is going to be positive. So when at degree 3 with positive, what is the end behavior? Yeah, the graph, like remember the x cubed, how does it look like normally? It's an S-curve with a is positive, which side up? Y side up, left side down like this, right? What is the maximum turn with degree 3? So maximum turn is going to be degree 3 subtracting 1 is 2. So like this, right? Okay, so when we are done, it should kind of look like that. And we're going to try to graph it with the points that we already have, right? We have x equal to negative 4, which is supposed to be touching.
So anytime you look to the maximum turn, you got to subtract 1?
From the degree. All right, and then x equal to 2, which is supposed to be crossing. And the y is like negative 32 way down here. Is it okay? And it's supposed to look like this guy. So if that's the case, I'm going to start like here, right? Up here like this arrow. When I get to 2, I'm supposed to cos it, right? So go down and cos it. And then what? Go to negative 32, and then go back to -4 and do I keep going now?
No.
Because I touch it and I'm supposed to touch it and do what? Turn around and bounce back, right? Are we okay with that? Okay, so that's that. So if something slightly different from a different question, if it's a degree, say 5, and then A is negative, so again it's odd, right? Odd leading power is going to be one side up and one side down. With A is negative, which side up? The left side up and right side down. What is the maximum turn? It's going to be 5 minus 1 equal to 4, so it's going to be like 1, 2, 3, 4, like that. Is it okay? So this is the odd with the A equal to negative. How about if I have an even leading power? So say this is a degree 4 with A is positive. So you want to think about like something you know, like quadratic with the square. So quadratic with square, what is the end behavior? The both sides is going to be up for A equal to positive. So if it's degree 4, the maximum turn is going to be what? 3. So 1, 2, 3, like a W. So very similar, degree 4 with maximum turn is 3, but A is negative. A negative is going to be both side down. And maximum turn again is going to be 3. So similar, 1, 2, 3. So look like an M, something like that. So I don't know which one is going to be on the final. They are all possible, okay? So you need to know all of them. We'll say if x equal to 1 is a root of 0 for the function 2x cubed plus 3x squared minus 8x plus 3, and we want to be able to find all zeros. Okay. So, if that's the questions, what do I need to do? So first we need to try to bring the degree 3 down, right? So if you have degree 3, mean you have how many zeros? When you have degree 3, you can have up to how many solutions? 3 solutions. It's not a trick question. So they already gave you one, right? So if you don't know how to do any of that, at least give me back one solution. And to bring it down, like you say, we first use division to get to degree 2. So once we are in degree 2, then we can solve it by what? You can try factor or quadratic formula. Okay, so you can do factoring or quadratic formula. Later. You have to go. Okay, so let's see. So we need to divide. Can we do synthetic division for that?
Yes.
So you have 2, 3, -8, and 3, right? And what do I put in that corner? 1, because like this is x equal to what, right? So they already told you x equal to 1 from the divisor, so we got that. And we first do what? Bring down the 2 times 1 is going to be 2. And then we bring that up. And then now we have 5 times 1 is 5. Combine that we have -3. And then 1 times -3 is -3. Combine that we have 0. Is it good or bad? Good, because I want it to be a solution, right? So my remainder is 0, so that works well. If it's not a 0, you probably want to double check it because they told you that's a solution, right? So we have no remainder. So basically it means the function equal to, what is your quotient here? To what? To x squared, because it's x cubed divided by x, plus 5x minus 3 times my divisor. If x equal to 1, what is my divisor here? It would be x, move the 1 back to this side, so x minus 1 equal to 0, right? So it's going to be x minus 1. And then I have to factor this, right? So let's try to factor. I'm going to not use the board today because it's recording. So we're going to do factor on here. So we have something times something equal to a times c. A times c is what? -6. And add together equal to b, which is 5. So what would the two number be? How? What would be that two numbers? 6 minus 1 is 5. 6 times -1 is -6. So I'm going to go back here and break it into that two number, plus 6x minus 1x, and bring down my 2x squared, bring down the -3, x minus 1 hang out on the back, and factor by grouping them in pairs. So the first pair we can pull out 2x, and then we have x plus 3, and then the second pair we can pull out -1, and then we also have x plus 3. Okay, so x plus 3 is a factor, and then we also have 2x minus 1, and then we have an x minus 1 here. This is the function. Okay, so those are your factors, right? And what are the zeros? So all three of them, right? We have x equal to -3. We have x equal to basically 2x equal to 1, and x equal to 1/2. And then we have x equal to 1. So make sure you give me all three back, okay? Even though 1 was given to you. Because this is degree 3, so you should end up with 3 answer up to if they're real solution. Any question on that? So if this given you 1, 0 to find the rest of it for degree 3, you divide, and then you can factor or use quadratic formula. Alright, so let's see the next one. The next one on the test, a lot of you missed that. Which is 3.5 with the rational function. Rational function are the one look like fractions, right? And we need to be able to find two things and two sentences to graph it. So what are some of the things we need to know when we are graphing a rational function? So r of x equal to, yes, oh, I thought you have a question. 7x squared minus x plus 2, x minus 3. Feel very strange recording it, so If you guys have questions, let me know. All right, so this is the rational function. So for this particular question, they want to know what is the vertical asymptote, what is the horizontal asymptote, and what is the slant asymptote. So the three type of asymptote, if they have it. Anybody remember how to find vertical asymptotes? You set the, people are shaking their head. You're setting the denominator equal to 0. So basically, we want to find out what x cannot equal to. What is the x values the graph have to skip. And vertical asymptote also tell you how many pieces of graph you're going to have. So to set the denominator equal to 0, we basically just have x minus 3 equal to 0, right? So what is the vertical asymptotes? Okay, some of you say 3, but I cannot give you full credit for 3. It needs to be what? X equal to 3, because it's going to be a vertical line, right? So don't forget to write in the form of x equal to some number. Are we okay with that? All right. How about horizontal asymptotes? So we say compare to the highest power on top and bottom, right? So this is kind of a shortcut. So if you're taking like calculus class, they may do the limit, but it would be for later. Okay, so for this particular level of college algebra, they allow us to do this. So we have basically R of x. What is the highest power, top and bottom? Which one do you see? 7x squared is the highest power. Do I have x squared at the bottom? No. If I don't have an x squared at the bottom and I want to force one there, this x squared need to multiply by a 0. So we basically pick up the leading coefficient top and bottom. And then that means y equal to 7 over 0, which is what? Which is what?
Oh, y.
When you have a 0 as denominator, that means what? Not possible, undefined. So you have no horizontal asymptote. Because this means 7 out of nothing, right? So you cannot have something out of nothing. All right, how about slant asymptote? When do we have slant asymptote? Only if when the top is top is exactly 1 degree higher than the bottom. How about this particular question? Does it have a slant? Is it top 1 degree higher than the bottom? Yes. So this one, yes. How do we find it? To find it, we need to use division. Very good. And then we will set y equal to something. Y equal to the, you're dividing, so you're going to get the, like after division, the answer is called what? Quotient. Okay, need a little bit studying for this one. Okay, so slant asymptote, only when the top is 1 degree higher than the bottom. To find it, we use division, and the slant asymptote would be y equal to quotient, okay? We ignore the remainder. So for this one, can I do synthetic divisions? Yes. So what do I put at on the side? Yeah, you're right. So 3 because it's from the divisor, right? Which is x minus 3 equal to 0, x equal to 3, right? And inside we have 7, negative 1, and 2. Go ahead and finish that part for me, please. Okay, what would be the slant asymptote? Plus 20, but don't forget set it y equal to, okay? So that would be an equation. And then we ignore the remainder, right? So sometimes students even don't finish that part because the remainder doesn't matter for that slant asymptote. Okay, any question on this? This seems to be a question a lot of students missed on the exam too, so make sure you review that a little bit. If no question, we're going to move on to the next question, which will actually graph the rational function. So the next question say they want to sketch the graph for r of x equal to 6x minus 1, x plus 2. They want you to find all the intercept. So if they say all the intercept, that would include what kind of intercept? Y-intercept and x-intercept. So x-intercept, y-intercept, and then they want to know the asymptote. What kind of asymptote can I have? Vertical and horizontal and slant asymptote. Does it have a slant for this one? No, because the top is not 1 degree higher than the bottom, right? So we will have vertical asymptote and horizontal asymptote for sure. No slant because top is not 1 degree higher than the bottom. So for x-intercept, we set y equal to 0. For y-intercept, we set x equal to 0. For vertical asymptote, we set denominator equal to 0. Very good. For horizontal asymptote, we do what? We need to pick up the leading coefficient. Thank you. So it's going to pick up the leading coefficient on top and the leading coefficient at the bottom. So if they don't have that particular term, we just match it and multiply a 0 with the term. Okay, so setting y equal to 0, we have 0 equal to 6x minus 1, x plus 2, like that, right? And then what do I do with that? Multiply x plus 2 both sides to get rid of the denominator. Very good. So on the left, it's multiplied by 0, so it's still going to be 0 equal to 6x minus 1. And then we solve for x, right? So x equal to 1 over 6 is correct. So it's like 1, 6, comma 0, right? For your x-intercept. Okay, for y-intercept, we're going to set x equal to 0. Can you go ahead and find that for me, please? Y equal to -1/2, very good. So the y-intercept is when x equal to 0, y equal to -1/2. Okay, a little bit messy, this one. Okay, so setting the denominator equal to 0, what is your vertical asymptotes? Thank you. X equal to -2. Don't forget to write this vertical asymptote as x equal to a number to represent vertical line. And then for the horizontal asymptote, which one has the highest power? To the first power, right? So y equal to 6x to the first over what is the leading coefficient at the bottom? 1x, right? So it's basically here. So what is your horizontal asymptote? Y equal to 6. Very good. So y as a horizontal line, which is y equal to a number, right? So using all that, we're going to try to graph it. Okay, so I have to do it here in order to be able to record it. So what can I put on the graph? The intercept and the asymptote. So I have one vertical asymptote, which is x equal to -2, right? Which means how many pieces of graph I'm going to have? It's divided into how many sections? You should have one piece on the left and one piece on the right. So one vertical asymptote means two pieces of graph. Is it okay? All right. So, and the horizontal asymptote, oh, x equal to 6, way up there. Sorry about that. Didn't really think ahead. Okay. All right. So this means you can have one piece here or here, one piece here or here, but not both because it's a function, so it has to pass the vertical line test. So I'm going to put down my intercept and see how it look like. So my intercept is x equal to 1/6, so very close to 0. And then y equal to -1/2, very close to 0. So if I have to go through these two little points out here, on the right-hand side, I'm pretty sure it's going to be on top or bottom. If the graph have to go through these 2 points, is it going to be on this side or the top side? Bottom or top? Bottom, because I have to go through these 2, right? And then once my graph goes through these 2 intercept points, it's going to get close to what? Asymptote. So graph has to get close to the asymptote and try to make it smooth, get close to the asymptote. Are we okay with this piece? Because it has to go through the intercepts. Okay, so on the other side, is it going to be on top or bottom? Top, because we already figured out all the x-intercepts, so it's not going to cross here. And if you're not trusting me, you can try to test a point. You can test like x equal to a -3, so on this side. So you should see a y value, which is big and up here, okay? But I know it doesn't have any more x-intercept here, so it has to be on the other side. So it's going to get close to the asymptote just like that also. Are we okay? So get close to both sides of the asymptote. Questions? So you will have one kind of ask you to graph all the different functions from exam 2. Okay, moving on to exam 3. Hopefully you still remember a lot of them. One of them will ask you to solve something like this. So our problem is the unknown is in the exponents, right? So what technique will I use for this particular question? Mm-hmm.
Do you get 27, you account for the 27 value, you do x minus 4 equals 3x?
Close, but I think you're thinking about getting them somehow canceled, right? So in order to cancel them, they need to be same what? Base. So I need the same base on both sides. If just one term on each side, then I can cancel it, right? What base do you think I can change that to? 3 would be good. So 27 is 3 raised to what power? Right, if you're not sure, you can say 27 is 3 times 9 and 3 times 3. So clearly this is 3 cubed, right? But don't forget, you already have some kind of exponent here. Is that okay? Alright, so equal to 9 is the same as 3 to the second power. Is it okay? So I'm going to replace my 9 with 3 squared. But don't forget, this question already has 3x there, right? So if I combine, I don't have to combine that first, but like I see they have the same base, one term on each side. Now I can do what? Cancel the base. Is it okay? So it's going to be 3x minus 4 equal to 2 times 3x, right? So on the left, now we have 3x minus 12 equal to 6x. So now we just need to solve it, right? I would move the 3x to the other side. So negative 12 equal to 3x, okay? And then the last step, we need to do what? Divide by 3 both sides, so x equal to negative 4. Is it okay? Can x equal to negative 4? Cannot? Why not? You can. The only restriction is like base of log and answer of log. So this is not even log, so don't worry about it. Okay, so and if you plug it back into the original function, it should check. All right, so you have one like that. Are we okay with this one? All right, the next one, we may have one similar to this, which is solving log base 3 x minus 5 equal to 4. So if we have a question like this, we need to do what? Change to exponential. So if we stuck with log, we will try to change it to exponential. Okay, so your base is 3 raised to the 4th power is its exponents equal to x minus 5. What is 3 to the 4th power? Anybody? 81, very good. So 81 will equal to x minus 5, and x will equal to 86. Are we okay with something like that? Okay. Let's see how old is this test. But over time, they changed the test a little bit. So just want to make sure we show you all the different type of question could be on the test. And again, if you want to buy the review, it's from the department, $1. The money go to the math club. But if not, use your 3.0 exam to study for the final. And also the question we did this week would be similar type. All right, there's another log question. Ask you to solve log base x. Base 10x log base 10. It's supposed to be 2x plus 5. Sorry about that. Equal to log 12. So again, if you don't see a base, it means base what? 10. Okay, so if we have something like that, can I go ahead and cancel all the logs? Not yet. Like this is one of the common mistakes. People start canceling it. When can I cancel it? If just one term on each side, and they have the same base of log, then you can cancel it. So we're not quite there yet because I have more than one terms on the left-hand side. So I need to somehow get them together. How do I do that? somehow combine that, but like we're using some of the log property. What log property can we do that? We can write them as a single log, so single log. So if I write them as single log, addition will turn into multiplication. Very good. So go ahead and do that. So logged, we're going to multiply x times 2x plus 5 equal to log 12. So now I only have 1 and 1 on each side, right? So I will be ready to cancel the log. Got it. So it's going to be multiplied. The left hand side will give me 2x squared plus 5x equal to 12. And then I need to do what? Set it equal to 0. So 2x squared plus 5x minus 12 equal to 0. And this is what kind of function? Quadratic. To solve quadratic, or we can do what? We can factor or quadratic formula, right? So let's do that. Yeah. We can solve by factor or quadratic formula. Okay, so I have to finish this on the page in order to record, so let's try it with this limited space. Something times something equal to A times C when they add together equal to B. A times C is what? No, be careful. Negative 24. Okay, B is 5. Okay, and what two number multiplied would be 24 and combined would be 5? 8 and you say negative 3? Okay, so 8 times negative 3 is negative 24, combined is 5, right? So that looks good. I'm going back to the middle term, break it to plus 8x minus 3x, so it's still 5x. Bring down the first term, bring down the last term. Okay. All right, so now pull out the what can I pull out? 2x, okay. And inside I would have x plus 4. The second two terms I can pull out minus 3, so it starts with negative. We pull out the negative, and when you pull out negative, I have to change this side to positive. So inside I still have x plus 4. So again, they're supposed to match, right? If they don't match, like probably something not quite right, go back and check. So the factor will be x plus 4 and 2x minus 3. So now, after we solve it, one of the solution is x equal to negative 4. This basically means 2x minus 3 equal to 0, 2x equal to 3, x equal to 3 over 2, right? Is that okay? Final answer? It cannot be negative because the position of here is n sub log, right? So n sub log all need to be greater than 0. So we throw that away. If we plug in here, not okay. But if I put the second answer here, this look like it's still going to be positive. If I plug it in here, because it's adding another number, so both of them are positive, so that seems to be okay. So you have to check this one. Like, likely you need to throw out some answer. Are we okay with that? Yay. Okay, so that would be some interest rate questions, such as the next two. So one of them will be if you invest $4,000, if it's compounded monthly, at 3% for 10 years. So we want to know how much money you have after that. So money you have at the end. So first of all, we have to figure out what formula should we use this. If it's compounded monthly, which formula would that be? Remember there are two interest rate formula we have for this class, right? Which one would that be? 1 plus R over N. So when you need to find those formula, where can you find them? The matching formula sheets. A equal to P 1 plus R over N and T, right? So help me to plug it in. P is $4,000 is your principal. 1 plus the R is, yeah, it's 3%. Don't forget to change it to decimal. Like you say, it's going to be 0.03, right? Over N is 12, because monthly mean like you compound 12 times a year, right? And then ways to how many times a year again? 12 times a year for monthly, and how many years? 10 years, sorry. I cannot see it. Okay, so this means 12 times a year for 10 years. So this basically represents how many times it's going to be compounding. Okay, so you're going to need to keep those numbers in your calculator. Don't round it until the very last step. So some of you round it in the middle. That would not be good. So 0.03 divided by 12 plus a 1. So inside is like a 1.0025 raised to 120 times, right? So you should keep that very long decimal number in your calculator until the very last step, okay? Don't round that. If you can do it in one step, that's okay. What is the final answer? 3,897.41 cents, right? Are we okay with something like that? So make sure you practice how to use the calculator and be able to do it. And it started at 4,000. After 10 years, it's a little bit more than 5,000. Still sound reasonable. It's not like 5 million or some weird number, right? Okay, so don't forget to change the decimal, the percentage to decimal. And other question you may see is investing maybe like a $6,000 at 5% compounded continuously. So we want to know what will you have at the end of 2 years. Okay. So if it's continuously, then we should use what formula? The PERT, right? A equal to PERT. And help me to plug it in. The principal is $6,000. E is in your calculator. Interest rate is 0.05. We convert the 5% to decimal times 2 years. Okay. So 0.05 times 2 is 0.1. And 6,000 E. So make sure you know how to plug it to the calculator. And don't round your answer until the very last step. If you are able to do it one step on the calculator, that would be fine. What do we get? 0 after we round would be 3 here. Okay, are we okay with those? Those are designed to give you points. So hopefully you know how to do it. We want you to get all the points you can. And the next question is similar to the one you see in 4.5. Okay. Trying to look at two over at the same time. Keep shopping. So if they give you a population formula, we give you a function and say the population grow, follow this function, P of t equal to 380 e raised to 0.02 t. So this is your population growth function. They want to know a few things. They want to know what is the population when time equal to 0. And then they also want to know the growth rate. And then when will the population reach 722? Okay. All right, so what is the population when time is 0? It's basically this number, right? 380. So for this particular one, it's by insect. And if you want to plug in t equal to 0, then the exponent is 0. Anything raised to 0 is what? Anything raised to 0 is 1, and 380 times 1 should still equal to 380. So if you want to plug in t equal to 0, you should still get the correct answer, okay? All right, so what is the growth rate? How many percent? 2%. So 0.02 is the number, but they want rate means the percent, so change 0.02 to percent, 0.02 to percent is going to be 2%. Is that okay? All right, when we reach 722, so what did they give you? P of t is 722, so we plug that into our function. So it's going to be 722 equal to 380 e 0.02 t, right? So we need to solve for what? T, because they asked when, right? So first we need to do what? Divide 380 because we are solving for t, so we want to make this right-hand side more simple, right? So get rid of this number, divide 380 both sides, and then we will get what? 1.9 hertz equal to e 0.02 t. So the unknown is in the exponent, so I need to somehow bring it down. In order to bring it down, you need to raise ln both sides. So usually we can raise log, but this particular one have e, and when you see e, ln usually work better. So I'm going to have ln both sides. Make sure you show me the step on the test, okay? Otherwise you may not get full credit. Okay, after we raise both sides with ln has a property allow us to bring the exponents down, right? So this would be ln of 1.9 equal to, I bring down my exponent, ln e. Is that okay? What is ln e? Ln e equal to 1, perfect. And then all I need to do is solve what is 0.02 t equal to my ln of 1.9, right? So to solve for t, we need to divide both sides by, very good, 0.02, 0.02. So t is about 2 decimal places, and we have
4.
so ln of 1.9 divided by 0.02. Make sure your parentheses like close correctly. If you have a graphing calculator, even me, sometimes I try to input it quickly. Is it? Yeah, let me try. What I have there maybe not right. ln of 1.9 divided by 0.02. Oh, what did you say? I'm sorry, say it one more time. 32.09. Is that what everybody get? Sorry about that. 0.92, right? Okay.